Determine if the following function is concave up or concave down in the first quadrant. Now, I don't know how particularly important that first quadrant information is. All right, so Kamala, I think you were the only one that was here on Monday. So do you know if that's concave up or concave down? And how do you know it's concave up? Well, that's part of it. It's concave up because that 2 is positive. That's part of it. But what's the other part of it? Do you remember? The exponent. And why is it concave up? Because of that exponent. Because it's greater than 1. All right, so if the exponent's between 0 and 1, so it's a fraction that's smaller than 1 but bigger than 0, it's concave down. If that exponent's larger than 1, then it's concave up. Now, the coefficient does need to be positive also, by the way. Otherwise, it does weird things. We can talk about that later. So it is concave up. And that's all there is to the question. Should you get that one right? Yes, I agree. All right, what's next? Problem 9. Oh, and you can graph it too. FYI, concave up looks like this. That's up, and it does that. That is down. There you go. Now you know. Solve the equation and check for extraneous solutions. All right, so we're going to solve 2 times 3x minus 1 to the 4th power is equal to 32. So how in the world do we do this? Do you remember? You were the only one here. How do you do it? Nope, too much work. Way too much work. What do you think? You could. So you could type in y1 the 2 times 3x minus 1 to the 4th. And in the y2, you could type the 32, and that would work perfectly well. And then what do? You look where they intersect. And they're going to intersect in more than one place, by the way. So that is one way to do it. We're going to do that in just a minute. I like that idea. Well, because you got it raised to the 4th power. Yeah, it's way too much work. So what you can do algebraically, though, is you can divide both sides by 2. So let's write that over here. So now I have 3x minus 1 to the 4th is equal to what? 16. 32 divided by 2, is that 16? And then you take the 4th root of both sides. So when I take the 4th root of 3x minus 1 to the 4th, that just gives me 3x minus 1. So if I take the 4th root of something raised to the 4th power, that just gives me whatever I got inside parentheses. But on the right-hand side, since I'm taking an even root, I have to put a plus or minus over there. I have to. If it's an even root, it has to be a plus or minus. Has to be. And then what's the 4th root of 16? Can you figure that out? Do you need a calculator? How would you do that? No, the 4th root of 4 is something really big.
Four. No, three.
No, 2, because 2 to the 4th is 16. Very good. Okay. That's all right. So then you just do what? So 3x minus 1 is either negative 2 or 3x minus 1 is positive 2. Add 1 to both sides. 3x is -1 divided by 3. So -1/3 is one solution, correct? What's the other? Add 1, 3x is 3, divide by 3. Is that 1? Okay, so let's see if we can't try that. The calculator. Okay, now the only caveat with the calculator is you are going to get a fraction, so you're going to have to know how to convert that. I mean, you're going to get a decimal, so you're going to have to convert that to a fraction, which is not that big of a deal. Okay, so you told me to put in y1 2 times 3x minus 1 to the 4th power, correct? And then in y2 put 32. And I'm going to do a standard window, so I'm going to go zoom 6. Oh, 32. So I'm going to have to change the window in the y direction to get that 32. Oops. So let's do 35. There we go. So it's crossing in 2 different places. Now I think I can look at that one right here, see where my arrow is, where my cursor is. I can figure out that's 1. I mean, it looks like it's intersecting at 1. Does it look like to you? Okay, now this one, let's find that intersection. And then you're going to have to use a little bit of knowledge from arithmetic to know that the fraction you're going to get, and maybe it will give it to me as a fraction. I don't know. We'll find out. Okay, so let's find that intersection there. So second, calculate intersection, and then we go enter, enter, and that's pretty close to that intersection. You see it where it's blinking? So I'm going to hit enter a 3rd time. Yeah, so I need to know that well, I don't need to know. I actually can figure this out. -3.3333333, that's -1/3. Okay, but if you don't know that, you want to know how to change that to a fraction? Okay, so it just calculated x, correct? So I'm going to go back to my home screen, and I'm going to take that x, the x, and I'm going to go to my math menu, and I'm going to change that x to a fraction. It'll take whatever x it just calculated and make it a fraction. Sweet. So that is a good way. Do you need a calculator today? You got one? Okay, so that is a really good way to solve this. So put one side in y1, the other side in y2, and then find the intersections, the 2 intersections. One of them is going to be an integer, can almost guarantee it, and the other is going to be a fraction. But when you calculate that fractional intersection, just go back to your home screen and say x, make that a fraction, and it will for you. Very good. All right, what's the next one? Solve the equation and check for extraneous solutions. Now this one you could do on your calculator. I think this would work really well. Oh, you can't see that, can you? I gotta share again. Now it should come up over there. Maybe. This was one of the main things. Okay. I'm one of the only people on this campus that can figure this out. All right. So this one would be a good one to put in your calculator too. How in the world do we solve this? Well, there's a couple of different things we can do here algebraically. I have x to the 1/2 is equal to 3. So to clear that exponent, I want to raise the left-hand side to some number so that when you raise it to that power, you multiply the exponents and it cancels the 1/2. That's a long-winded explanation to say, if I raise x to the 1/2 to the second power, yeah,
But what did you do? What's half, what would be half for?
okay, so, but it's an exponent. So when you raise something to the 1/2 power by the laws of exponents, that's equivalent to the square root of x. So by definition, when you raise something, let's write this over here, to the 1/over power, that is the nth root of that by definition. So it doesn't have anything to do with taking half of it or anything like that. It does have to do with raising that to that power. Yes, it is a rule you have to follow. They call them laws, as a matter of fact. Okay, so if I square both sides, either way, I can square both sides. And what do I get? X is 9. And that is a solution. The square root of 9 is 3, correct? So that is the solution. X is equal to 9. Now, following Hamlin's suggestion earlier, could we graph this? And the answer is sure. Okay, so let me share over here. And the only reason I'm having to do this is because I'm recording it. And if I don't share that screen over there, you can't see it on the recording. All right, so let's try that. Let's see what happens. So in our y equals, in number 1, let's put x to the 1/2. What do you think? Okay, and in the other one, are we going to put 3? And I'm going to do a zoom standard. Oh, did I get the 3 in there? Oh, still 32. Boo. Now we should be good. Okay, so where is it intersecting? Looks like it's intersecting at 9 to me. But what I can do is I can calculate that, second calc, intersection, number 5, enter, 9. So the solution to that equation is 9.
So how does this, how did you know the other one would have 2 answers, but this one only has 1?
Because I knew that I was raising that to the 4th power. And when I take the 4th root, I have to put the plus or minus in front of it. So I know that because of that plus or minus thing. Now this is the square root. So it's not going to be the same. So I'm going to raise both sides to the 2nd power. And I won't get that to happen. Good question. All right, where are we? Problem 11. The number of females in law continues to show steady increases. The number of female lawyers in a certain country can be modeled by the function f of x equals 0.832 times x to the 1.325, where x is the number of years after 1940 and f of x is the number of female lawyers in thousands. What type of function is this? Is it a root function, a power function? You got to drop down here. A piecewise defined function, an absolute value function, or a reciprocal function? Why is it a power function? You're raising x to a power. So what's f of 25? So what are you going to do? 25, put 25 in for x. I'll let you practice that. What do you get? And they're telling you how many decimal places to the nearest thousandth. So that's 3.
So since it's at 8, that would make it 1 0, right? 59.210.
Yes. So, okay, so how do you do that? Actually, I'm just going to switch to the calculator on this computer up here faster. Okay, so what you do is you're going to evaluate that function at 25. So that function is 0.832. Times what? You're going to take the 25, you're replacing the x with the number 25, and you're doing what? You're raising that to the power of 1.325. $59.2098, but they want you to round it off to 3 decimal places. So you round the 9 up to 10. Okay.
I didn't know that's what.
That it is pretty simple. Okay, so part C. How many female lawyers will there be in 2040? So 2040 means the year 2040. And since this model is the number of years after 1940, does that mean we're going to evaluate this at 100? So 2040 minus 1940 is 100. So we're going to evaluate this function at 100. So what do you get? Throw 371.641, rounded off to 3 decimal places. Okay, so now we need to figure out how to put this into my lab math without getting it wrong. Okay, so this means there were how many lawyers in the year 2040? Okay, so this is in thousands. That's what they told me. So to be able to type it into the field, I need to take that number and multiply it by 1,000, because that tells you how many people, how many women you have. So what do we have? 371. So move the decimal place 3 decimal places to the right. So 371,641. Tricky. Hmm? Oh, wait a minute. Do I have it in the wrong place? I do have it in the wrong place. This is 371,641. I ignored this part right here. Just totally ignored it. This particular app that I'm using is not near as friendly as on my iPad. Okay. So let's write what we were supposed to write in those two fields. This means there were how many female lawyers in what year? So 25 plus 1940 is 1965. So in 1965, there were how many? Well, we had what? 59.210, so there are 59,210 female lawyers in the year 1965. Then in 2040, there were 371,641. Okay. Now, the tricky part of this question, so make sure when you're doing your review that you make note of this. The tricky part is in those first two fields is to multiply it by 1,000, correct? That's the part you need to remember. I will check it and give you partial credit if you don't, but be sure you look at that and multiply it by 1,000. All right. The revenue in billions of dollars from artificial intelligence for enterprise applications in a country for the years from 2016 through 25 can be modeled by y equals 0.49 to x to the 1.194, where x is the number of years after 2015. Graph the function for the years from 2015 through 2030. Is the function increasing or decreasing? Is it concave up or concave down? And I think that's it. Oh, according to the model, the revenue in 2038 will be about how many billion? Okay, so which graph is it? Why is it B? It's because when you did it on your calculator, that's what it looks like. That works. I mean, it's okay. Just between the four of us, it has to be B or C, correct? It can't be A or D. Why can't it be A or D? Because since the exponent is 1.194, and that is greater than 1, it is concave up. So it's got to be doing this. Has to be. So it can't be D, and it can't be A. Those are both concave down because they're doing this. Okay, so it is concave up. It's also increasing. Power functions increase. That is what they do. If the coefficient's positive and the exponent is positive, they're going to be concave up or down, but they are going to be increasing. So if you graph this using the window, what, from 0 to 15 and 0 to 20, then you can see that it's B. I'll let you do that. Okay, so according to the model, the revenue in 2038 is going to be what? Well, what year is 2038? 2038, and what's this aligned to? 2015, so is that going to be, is that 23? So are you going to evaluate this function at 23? So what's that going to be? 0.492 times what? 23 to the, what are we raising it to? 1.194? What do you get? And they're telling you to round it off to 3 decimal places. 791? Is that what you guys got? Family's like texting BG. My daughter's 35th birthday was yesterday, so they're planning her birthday party. Okay, now we have not talked about piecewise defined functions yet, but I'm going to soldier ahead anyway. And we'll talk about them as we go. So what's a piecewise defined function? A piecewise defined function is a function that has a different rule to find the y value depending on where you are in the domain. So depending what your x value is, you use one of multiple rules to find the y value. So different rules for finding the y values for a particular x. So this particular piecewise defined function is defined as you got x squared minus 3 if x is less than or equal to 0. So if your x value you're evaluating this function for is 0 or negative, so less than or equal to 0, to the left of 0 on the number line, then you're going to use the x squared minus 3. If it's bigger than 0, then you use the x squared plus 3 to evaluate the function. Okay? Select the correct choice below, and if necessary, fill in the answer box to complete your answer. Then what's f of negative 3? You either use the x squared minus 3 or the x squared plus 3 to find the y value. What is it? Do you use this one? Because x is a negative number, you got to use the top rule, the top equation to find the y value, because it's told you that that's the one you use if x is a negative number. So what do you get? Five? Is that right? 9 minus 3. Nope, 6. You didn't hear that. 6. Just erase that. Isn't that why we have erasers? Is it 6? Am I right? All right. How about f of 3 though? Do you use this rule here? Because your equation says if x is a number bigger than 0, use the second rule. So what's that going to be? 3 squared plus 3, is that 12? Is it cubed? It is cubed. I can't read and can't see glasses. It's cubed. So is that 30? Helps if you put your glasses on. All right. The absolute value function is a v. So which one is it? Can you graph it on your calculator? Absolutely. Now, how do you graph it on your calculator? Because you might want to know where the absolute value bars are. Okay, so I'm going to go to my y equals and clear out what I got in there. Isn't that a beautiful equation? Look at that. That is the equation, the function for the normal curve, the normal curve. All right. So absolute value, if you go to your math menu and you go over to number, which is the second menu to the right, number 1 is absolute value, ABS. So when I hit enter, you go back to your y equals and it gives you the absolute value bars. You type in the x. And then I'm going to do a zoom standard because I know this window's out because I was graphing the normal. There you go. It's a V. Okay. Now, the other thing I know, it can't possibly be A or D. It cannot. It cannot be A or D. Nope, 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 nope. And I know that because neither one of those are functions. They're not functions because they fail the vertical line test. I can draw a vertical line through it and hit the graph in more than one place. And I know it's not B because there's no negative in front of it. And that's what turns these things over, right? Is putting that negative in front of it. Because if you think about a parabola opens down if the coefficient in front of the x squared is negative. So an absolute value will open down if there's a negative outside the absolute value bars. There is not. So it has to be C. Okay? What's f of -7? What's the absolute value of -7? 7. What's the absolute value of 8? What's the domain of this function? Now you can, what's that? No, what's the domain? What can you plug in for x? Is there anything you can't plug in for x? Pardon? It would be. And the reason, there's a couple of things you can look at to determine that the domain is the set of all real numbers. First of all, what's happening to those arrows in the x direction on that thing? What's going on here? Are they doing that? So in the x direction, the arrow goes to the left and to the right. So the domain's everything. And the other thing is there any number you can't take the absolute value of? Nope. And then how do you take the absolute value, which I kind of glossed over? How do you take the absolute value of a number? If the number is negative, you just remove the absolute value signs and make it positive. Because by definition, absolute value is the distance from 0. Distance is positive always. That's a positive quantity. How far is -7 from 0 on the number line? Is it 7 units from 0 on the number line? Yep. How far is 8 from 0 on the number line? 8. So absolute value is always a positive quantity. Now, solving equations, you might get negatives, and we'll talk about that just right now. So 15, solve the following equation and check graphically. Well, shoot, I could find the solution graphically if I want to. But let's show you how to solve this algebraically, and then we'll go graph it. All right. Two solutions. 2. So when I solve that, there's going to be 2 numbers I can plug in there and satisfy the equation because of the absolute value bars. So one of them is like 6 and a fifth. Because if I take 6 and a fifth and I subtract a fifth, do I get 6? And the other one's going to be what? -5 and 4/5. Because if I have -5 and 4/5 and I subtract a fifth, do I get -6? The absolute value of -6 is 6. Now, how do I figure that out algebraically? Okay, are you all awake and listening? I'm going to yell at the 11 o'clock class the same way. Here is how you solve an absolute value equation. Are you listening? Don't do it any other way than the way I'm telling you. You take what's inside the absolute value bars. That can equal -6. Because when you take the absolute value of -6, you get +6. You take what's inside the absolute value bars and you set it equal to +6. Because can you take the absolute value of 6 and get 6? So what's inside the absolute value bars must be either -6 or +6. It's got to be. Only way this is going to work. Now solve the 2 equations. Add a fifth to both sides. Add a fifth to both sides. So either X is, take your calculator out and tell me what that is. Negative 29/5, I believe. And this is gonna be, woo, excuse me. Oops. Got all sorts of things going on here. Blow it back up a little bit. Okay, so what's that gonna be? Is that 31/5? So I've got negative 30 over 5 plus 1. Negative 30 plus 1 is negative 29/5. I have 30 over 5 plus 1 over 5. Is that 31 over 5? You could certainly use your calculator to find those two values. Doesn't bother me a bit. But did you notice I got, now, let's go graph it. Let's show you that you get two answers. Okay, so I am going to graph the absolute value of, let's go clear that out, start over again. So math number 1, and what am I graphing? X minus a fifth? What's that? Oh, can't see it? Your sharing is paused. Yeah, we can see it. All right. So X minus a fifth, X minus 1 divided by 5 inside the absolute value bars. And then what is the other one going to be? 6. Two answers. Who knew? Okay, so let's find the first answer. So we're going to do second calc intersect, enter, and then I just got to move closer to one of the intersections. Negative 5/8. So we're going to go back to our home screen. We're going to take that X, and we're going to convert that to a fraction. Negative 29/5. What's that? It'll count it wrong, but I'll count it right. Okay, and then let's go find the other one. So we go back to the graph. We're going to go to calculate the intersection. And then we're just going to go enter, and then we're going to go move closer to that second one. $6.2. So we're going to change that to a fraction. So we're going to take X, math 1, 31/5. Is that what I got? All right. Problem 16. Piecewise defined. The number of banks in a country for the years 1935 through 2009 is given by the following function, where X is the number of years after 1900. What does this model give as the number of banks in 1970? So let's talk about this for a second. So X is the number of years after 1900. So the first part of this definition, the 81.3 plus 12,366, is good for x's less than 90. So that would be from 1900 to 1990. So it's going to be for the number of years after 1900 to be less than 90. Okay, and then the second one is for x is greater than or equal to 90. So that would be 1990 beyond and beyond. So in 1970, the number of years after 1900 would be what, 70? So are we going to use the first part of this to find that? The 81.3 times 70 plus the 12,366. What do you get? I think it's 18,057 is what I got. Okay, 2000, however, is 100 years after 1900. So would I use the second part to evaluate at 100? Negative 376.4 times 100 plus 48,689. So what do I get? I got 11,049. Okay. Which graph is it? By the process of elimination. Okay. First of all, look at the restrictions on the domain. The first part of the graph is for x is less than 90, less than, not less than or equal to. So that first curve must end at an open dot. It's less than. It has to end at an open dot. Which ones do not? That one doesn't. That one doesn't. So it's either C or D. All right, these are both lines. They're both linear functions. Okay, a line that has a positive slope does this. A line that has a negative slope does this. So the first part of that, it's 81.3x. 81.3 is positive. It's a positive slope. So does it have to be this one? It has to be. It can't be any of the others because I have a positive slope on the first part. The first part ends at an open dot. The second part has a negative slope. What's the slope? Negative 376. So the slope is negative. So the second part has to go down. It has to be that one. It has to be. Now at 11, I'll show you how to graph that on your calculator. So keep in mind, you can graph it. And I'll show you how to do that. But you should be able to, by the process of elimination, figure this out. Okay, I got 3 minutes, 2 problems. And both of these are using your calculator to find the function that best fits your data. So time permitting, I'll do these 2 problems at 11, but we will do this at the end of this next class. Well, actually, about midway through. This is section 3.5, and we're going to put this stuff in our calculator and let the calculator find the power function. Now, you've done this with linear functions. You found the linear equation that best fits your data. It's the same process. The only thing is, instead of calculating, so I'm going to go stat, calc, instead of calculating a linear regression, you're going to calculate a power regression. So which one is that? Oh, there it is. Do you see number A? Power regression. So it's the same thing. You put the data in and you run a power regression, and it will give you the coefficient in front of the X, and it will give you the power. That is all there is to it. Don't make this hard. Don't make this hard. All right, are there any questions? All right, we'll see you back here at 11.